Okay, so we're going to talk about some motion control. I'm going to start with a little visual of some of the status on some of the products, some of the motion products that you may or may not have in your facility. And I hope you can read that, but I don't think this actually came right off our website. Anybody have any Kinetic 6000s without safe off?
Not sure.
There we go.
Because safe off
Without safe off.
doesn't work on ours.
Right, without safe off. So yours are not obsolete. Okay. Those are in Silver Series right now. Some of the Kinetic 6000s. Now again, that's a pretty easy step forward. If you have to replace it, you go to the you can get the ones with the safe off headers on them. But just something to be aware of. Anybody have 8720s? Kind of large, no? Okay. Ultra 100s, Ultra 200s?
Don't be ashamed. Go ahead. Raise your hand.
We're a tree of trust here.
All right, I'm not going to go into a long discussion about servo motors specifically. Oh, I am going to, but I'm not going to go product by product here. If you have N series, W series, Y series, some of the integrated gear motors, these are all in various stages of silver or after. We do have some products, 1326ABs, they're everywhere. 1326AB motors, if you have those, especially some of the ones with the older encoders, we need to have a conversation about that. Cables, is anybody aware that we have made some cable changes on our servos in the last year or two? Yes, I know one guy in particular who is very aware of that. There have been changes to our motors that have involved cabling. So if you have an older, like an NPL motor, servo motor out on your floor somewhere, and it blows up, and you get the new one in there, oh no, I got a cabling issue. So just something to be aware of. I just wanted to throw that out there. Now the fun part. We're going to relive the nightmare scenario. We're going to live the nightmare scenario today. All right. So our nightmare motion control scenario that I've actually been through at one of the customers' locations that's probably in this room today. Okay, so your machine is down. So after, let's say you guys are really good at troubleshooting. We'll say after, what are you going to look at? Your machine is down. What's the first thing you're looking for? What questions are you going to be asking? Anybody in here in maintenance? Who's the first person who looks at the machine? It's the operator, right? The operators are usually pretty good with normal situations. They have a pretty good idea of when something really needs to be fixed, when it's beyond them. Not all of them, but many of them do. Especially the guys who've been around for a while. So after the operator calls in to maintenance, what are the first questions that are typically asked? What's the first question that you would ask as a maintenance supervisor, let's say?
Power on?
Is it plugged in?
Is the power
Is it plugged in and turned on?
So normal stuff, right?
When was it last working right?
Yep. Yep. Yep.
What's your problem?
So we're going to go through all the normal. We're going to go through the boot and reboot, right? We're going to make sure there's power everywhere. We're going to go through our standard. We're going to go through our standard. How much time is that going to take? Depends, right? Could take an hour, could take 4 hours. Who knows? But let's just say at some point you conclude that, oh no. Put it over here. Anybody have a servo motor ever go bad? Happens from time to time. Okay, so now you've determined the servo motor's bad. What are you gonna do first?
Look for the spare.
All right. So number one question, spare. What else? That's half the battle. Can we repair it? Can we repair it on site? How long does it take to repair? Huh? Day and a half at Total Control Magna Wine, right? So, repair can be an issue. All right? So what other questions we're gonna ask? Okay, is there a spare, can be repaired? Okay, a day and a half. I may or may not have a day and a half. I'm gonna say that could be a little low, but. Okay, so replacement where? So then we're talking, replacement means what? Let's say, so the question we have to ask is, if we don't have a spare, is it obsolete? Right? Is it obsolete? And we shake our hands and go, remember we had this discussion 2 years, this actually happened with a customer that's not in this room. We actually had the discussion, we looked at one of their machines, and sure enough, like 2-3 years later, the call came in, my line is down, I can't do anything about this right now, you guys need to help us right now. Okay, it's obsolete 2 years ago, it's still obsolete. If you tried eBay, what else can we do, right? So, repair, spare. So, reality is, we'll have the part stuck in the machine. Anybody have expensive parts in their machines? If something goes wrong with one of your machines involving motion control, what's the weak link? It's recovery from unforeseen circumstances, typically, right? I want to pitch integrated architecture for a second. That's where we have multi-discipline control, where we integrate motion control actually into the processor. So it's a lot easier to recover when all the logic is in one place, as opposed to drive here, motion controller here, PLC over here. Just something to think about. Okay, so we didn't mention this. Who's qualified to fix this? If you got a problem with the servo, how many of you guys who are on the plant floor how many of you guys would you consider yourselves motion control experts? I mean, you take a stab at it. A lot of us would take a stab at it. You might be able to get it back and up and running. How long can we can afford the machine to be down? Who's qualified to fix it? How long is it going to take? And the god-awful question, what do you mean it's obsolete? I don't have a spare. So we've determined we have a bad motor. We've got to do a retrofit somehow. I can't get one. It's weeks. We've got a real problem here. So what's next? Things that we have to look at when we're going to replace a servo motor. Will the motor fit? Is there actually enough room for it? Typically, are newer generation servo motors bigger or smaller than the previous generation? So if they're smaller, their shaft size has probably changed. We've got a whole bunch of mechanical issues here. You got any mechanical designers on site? You might, right? You might, but something to be aware of. Electrical, you're going for a new motor, you got to get the right voltage. There are a whole bunch of encoders. Has anybody seen and come across an obsolete encoder? Encoders actually are what drives innovation, because encoders change over time. The better encoder you have, the better tuning you can have. So that's why those things seem to change a lot. Okay, so you found a motor. Is a new motor compatible with the old drive? Could be, right? You hope it is. But you know what? A lot of times it isn't. So now all you're trying to do is, you've got a bad motor, all you want to do is replace the motor. Ah, shoot. What do you mean I can't just replace the motor? Now it's the drive too. Cabling. Got a whole bunch of different cabling. I mentioned before that some of the things that change over time, we change how you connect to the motors. Your cabling might not be right. What cables you have, are they long enough? How's your noise? Are they long enough? Anybody use flex cables? When you have a gantry or something that's moving, you might end up using flex cables. So, all right, so now we've got an old motor here. We want to get a new motor that performs the same way as the old motor, right? Is that what we want to do? Is the old motor oversized? Has the old motor been replaced before? What happens if you're an engineer and you have a servo motor go wrong? What are you going to do? Are you going to make it smaller in some way, or are you going to make it larger in every respect? You're going to oversize it, right? You got to make sure it'll handle the task. So what happens is if somebody's replaced this motor a couple times, chances are, and maybe they didn't have the right spare, they're going to go bigger and bigger and bigger. So what you're looking at might not be what's needed for the system. So what do you need to get off the motor? You got to find data off the old motor. You can't get everything right on the faceplate, but there's some things you need to go ahead.
That's where the original documentation for the machine,
Yes.
with a list of original parts as supplied.
Yes. Do we all have that for all our machines? Okay. Yeah, my experience too. Yeah, we had when I was a maintenance manager, we had a maintenance supervisor who he had one goal in life: job security, and literally any critical piece of documentation in the facility was buried somewhere in and around his desk. It's hard to deal with that if he's not in the facility. Okay, so now we've got a motor. Is the motor compatible with the drive? Okay, maybe we have to migrate a drive. There are a couple different kinds of drives. Standalone drives, you guys have CNCs? CNCs just needs a dumb drive. It needs like a plus or minus 10 volt signal. Where's the program on a standalone motion controller? It's on another piece of software, right? You have an old computer that can handle that 15-year-old motion controller? Anybody have an old computer around, like an old DOS computer? Is the software up to date? Do you have the right program? Is it current? Where the drive, you got to configure the drive separately, right? There are a bunch of parameters. Are there more than 5 parameters in a drive? Probably. Yeah. So, again, standalone motion controller with analog, there's a lot of these, but that can get you in a little bit of pain here. Okay, so let's just say you're lucky and you've got some network communication. So it just comes down to who has the drive software and where the parameters are they current. Has anybody here ever heard of Asset Center? There we go. We have a Rockwell sales guy who has. We have a piece of software that will allow you to store the latest and greatest programs. It forces you to, you take them out. If there are changes, it tracks changes. It can actually do disaster recovery on a machine. Just something to think about. So what we do in our integrated architecture world is integrated motion control. What is integrated motion control? All of the control is in one box. So you have the software, it's RS Logix 5000. Where's the program stored for the motion controller and the controller? Where's the drive configuration? That's also in the controller. It's all stored. So you don't necessarily have to go looking for that unless you've managed to blow up your control logics or compact logics at the same time. So we've got a bunch of different motion networks, analog. Most of you have probably used Circos if you have motion control in your facility. Circos is a very viable technology. We're moving toward Ethernet for bandwidth reasons. So you're replacing a drive. You got to do some things in a panel, right? It's, do you have drives sitting outside a panel somewhere? They're usually in a panel. Are they getting smaller or larger? Drives are getting smaller. What happens when drives get smaller? They're more susceptible to noise. Anybody still using painted backplanes? Don't. All right, so we've had a motor go down. Boy, that's a lot of effort to replace one motor. Hopefully a day and a half will get the motor replaced somehow, but if you're looking at a project, typically a machine's not gonna have just one ticking time bomb, it's gonna have others, right? Especially if it's something that's got an obsolete motor on it, chances are just about everything on there is obsolete. Can you replace it all at the same time? No. This is your perfect opportunity to start working on a phased migration. This is when you start talking about, okay, I never really liked that clutch brake. Can I do something about this? So, OEE on a machine. Anybody ever see a machine that's an absolute dog that will kill your OEE every single day? Anybody have one of those on your floor? We had a few of those when I was a maintenance manager. All right, so one of the things that we get out of integrated architecture is we're information enabled. It's very easy to pull a lot of information out of the control system. Something that can really help you here. So when you do a major modification on a machine, you guys have to do risk assessments if you fix something or you do a new project. Do you ever have to do a risk assessment after the fact? So the next question I'm going to ask is the previous generation of motion controllers and PLCs, do they tend to have a lot of safety built into them? Probably not. Just something to be aware of. So when you're looking at a risk assessment, you may have to do some additional work here. We had an event a couple of months ago where we talked about Mechatronics. So let's just say we went through all of this pain to fix a servo motor. Is that necessarily the best path to get from point A to point B? It could be. In the short term, your machine's down. I don't have time, right? I've got to get this thing up and running as fast as possible. Now I've got some other ticking time bombs on the machine. I want to start thinking about how I might want to change some things. Can I get a budget for that? What's the best motivation for getting a project justified? What will really motivate somebody?
Near miss.
A near miss, exactly. So once you have a near miss and you have some things that you want to get done on that machine, it's time to start thinking about it. Get it while the memory is seared, that the pain of the 3 or 4 days of lost production is right there. That's when you ask for what you really want on the machine. So what is Mechatronics? It's basically machine design, and you're putting all the people together to design a machine. It's a combination of controls, computers, electronic systems, and mechanical systems. We call it mechatronics. When you have something that you need to change on a system, and if you have to make a servo change, for example, do you have to make any mechanical changes? You are going to be making mechanical changes. We talked about a couple of them, right? You're going to end up with, you may change a gearbox, you may change some other things. Well, hey, let's go to the end of the earth here. What are we actually doing with that servo? Is it actually a linear application? If it's a linear application, and maybe it's only going 5 feet, maybe we actually have a linear servo motor that can do the same thing and integrates into our integrated architecture. So how much mechanical work does that save us? Potentially it saves us a lot of mechanical work, especially if we're talking about a phased migration, right? In a phased migration, we don't want to do everything all at the same time. So, oh yeah, that's working. Oh, okay, here we go. All right. So basically, Mechatronics is collaborative venture. If you're a controls engineer, do you want to do this by yourself? Hell no. You want to have mechanical guys involved in this. You may or may not have these people on site. You might. And there's some talented OEMs out here that can actually help you get from point A to point B because they do mechanical and electrical. So, what do you get when you start looking at the whole machine design? You get more of a sustainable machine. Maybe you'll get higher OEE. your risk is going down. This is the kind of stuff you can sell to management after the nightmare scenario. What can we do to help? We've got a whole bunch of design tools. Has anybody ever worked with Motion Analyzer? Motion Analyzer is our software package that basically you type in how far, how fast, how much mass, what do you want to do with it? And it spits out, okay, these are your options for servo motors and drives. You can do linear stuff, you can do rotary stuff, really powerful tools. So it can even give you tuning parameters. We've got a bunch of products that you guys may or may not know about. Linear motion. So again, when you're looking at that mechanical system, when you have that servo, very often it's driving something linear. You can eliminate a lot of your headaches by actually changing products. We even have a linear motor. Has anybody ever seen a linear motor? Linear motor has no bearings. What is a wonderful trait of a linear motor? Can go like, I'm exaggerating, but if you guys came to me with I want to launch something application, I'm going to recommend a linear motor to you. So, in any event, all these tools are built into Motion Analyzer. So once we get when we talked about our initial downtime situation, we talked about our servo. Our servo motor blew up. Okay, we want to replace it. What do we really want to do with our machine? So this allows us to start looking at some options as opposed to just blindly replacing what's in there. Let's think about making improvements. So I mentioned linear motors. We have some direct drive servos that you can plug right into the motors. Anybody ever seen any of our electric cylinders? Anybody have air cylinders? They make a lot of noise. How's your air usage? They leak? When you're doing a retrofit and you're looking at how much it costs to run a machine, that can be one of those things that management likes because they have some sort of sustainability initiative. All right, so basically, I mentioned Mechatronics because we look at the whole system. We don't just look at the servo motor that we just blew up. We plan it, we execute it, and we go all the way through the cycle. So again, another discussion about if you don't just deal in a reactive situation and you want to mitigate risk over the long term, you look at the whole system, not just the control system. So, Mechatronics. Collaborative venture between everybody. If you can get more than one person. Anybody have a safety committee in their facility? Does anything happen? Can you sneeze without somebody in safety reviewing it? In one of my previous incarnations, they actually hired a safety coordinator after their $500,000 fine the year before. They decided that maybe they could justify somebody for 10 years. This was back in the early 90s. But in any event, so what are you going to get? So I told you what Mechatronics is. We're increasing the value of the machine. It's a more sustainable solution. Chances are, anytime you've had a machine over a long period of time, there are things you want to do with it that you can't do. That makes justifying an upgrade a lot easier, especially after you've already blown up the first motor and you realize that everything else is a ticking time bomb. All right, so overview. I'm going to go back to the initial slide. I want to talk about a couple of specific products. Okay, anybody have Ultra 3000s? Ultra 5000s? We talked about Kinetic 6000. These are all servo drives. What do we, I heard Ultra 100, is that am I moving this?